Welcome back to part two. So, in this part, right, I'm going to again remind you guys of what the final project is going to look like. I'm wanting to focus on maybe just getting these rectangles, right, the blue and the red over there, and how they manage to stay together. And what those are, right, what these squares rather are showing us is the area of this of the square with this length side, right? Because when we're saying in Pythagoras that this side squared, right, our hypotenuse is equal to this side squared plus this side squared, what we're really saying is that the area of the square, right, the area of this yellow square, which is over there, which is showing this length, is equal to the sum of this area plus this area. That's really what we're saying. And this is just helping us to visualize that. So that's what we're going to try and build in today's lesson. So let's jump into it. We can see our triangle is a little bit different to the one we have here. We're actually drawing the third point over there, whereas this one is over here. But that's the way the cookie crumbles. So let's deal with it. Let's do it. Let's go ahead and try and just find the distance of this line and this line. So we'll jump into the whiteboard in order to show us how we could perhaps go about doing that. Okay, so here's my lovely and messy drawing. That could actually work. Maybe I can just get rid of some of these lines, kind of. Still looks quite messy, but it'll do the trick. So what we're wanting to do, right, our goal is that we want to eventually be able to find the distance of this line over here, called the hypotenuse, which goes from A to B. This is way too messy, actually. I'm gonna go again. So we have that side, and that side. And then this always has to be a 90-degree triangle, right? That Pythagoras only applies if it's a 90-degree triangle, meaning that the angle between A and B, the sides, is 90 degrees. So our goal is to find the length of the side. And the way in which we're going to do that is saying a squared plus b squared. But what is a and b? How do we know how long a and b is? Well, we know we have the following. We know that this is x1, y1, and then this is x2, y2. Okay? And we know that now we've defined this coordinate over here as the same y as point A over there. So that's our y coordinate is y1, and our x coordinate is the same as point B over here, big case B, uppercase. So this is x2. Now, these are just straight lines, right? These are straight lines going from A to there, right? Going from point A to point C and point B to point C. So if we're wanting to know what the distance is from X, from A to C, it's really simple, right? All we'd have to do is calculate what that distance is. If we're wanting to know what the distance is of B, we just need to calculate what this distance is. This distance over here is just x2 minus x1. This distance over here is just y2 minus y1. Right? So that gives you the distance of those points, and that will give you A and B. So let's put that into code. So let's make a new variable. We'll call it let's call it A, lowercase a now. And A is going to be equal to, as we just said, it's equal to 0.1 point A dot x point A dot x minus point C dot x, which is Cx. And we can test this. Let's just console.log it, which will be the easiest way to see. And if I open up my console, ooh, we're getting a negative. Why do you think we're getting a negative? Right? Should be a positive distance. The reason is that we're first taking point A, so we're taking this point over here, right, which you can see is less than, in terms of x, than this point. So we're saying a smaller point, smaller value minus a bigger value, we're always going to get a negative, unless we move it over here. Now all of a sudden it's gone positive. So an easy way we can always solve for this is by just taking the absolute value. The absolute value of a number is just cut off its minus, right? So the absolute value of -5 is 5. The absolute value of 5 is 5. So the way we can do that in code is we can just say ABS. We can put ABS around, save it, and now we see that we're getting positive regardless of where we are. Okay, so that's distance A. And then we could do the same for distance B. We can say let B is equal to ABS of point. Now we're looking at, to remind us, we're looking at B, we're looking at y2 minus y1. So we're saying point B dot y minus cy. And if we console.log b, let's get rid of a, or let's just replace a just to make sure that this is working. We should now get something different over here. Perfect, 200. And we can see as we move it up or down, we change it. We move it left or right, it doesn't change much. It changes a little bit because I'm not moving in a perfectly straight line. But cool, we now have this distance over here and this distance over here. In the next part, we'll look at how to label the distances and add the squares.